Sorry, this is a little squished in here. Whenever they tell you that it's the midpoint, you have to have a separate step that says what that means, that DE is congruent to EC, because E was the middle of this. So these two are congruent. And our overall plan of attack is I would like to prove that these two angles are congruent. And I know I could do that if I knew that these two sides were congruent, because of my isosceles triangle theorem. If the sides are congruent, then the base angles are congruent. And so that's where I'm going to end up. Now to prove these sides are congruent, we're going to go back to our triangles, right? So many of our proofs are just proving triangles are congruent so that we can prove their pieces are congruent. So to prove these two triangles are congruent, we're just going to say, hey, I know that these sides are congruent, AD and BC, because opposite sides of a rectangle are congruent. And then, hey, it's a rectangle, so they're all right angles in a rectangle, so D and C must be right, and then therefore D and C must be congruent, because right angles are congruent. And then we already proved this. These two are congruent because of the midpoint, so then we have side, angle, side to prove that these two triangles are congruent. And then now that these are congruent, then their pieces are congruent by CPCTC, and then by isosceles triangle theorem, if the sides are congruent, then the base angles are congruent. And there you have it. Woo!